Okay, we're kicking off this third unit in statistical reasoning with scatterplots. Scatterplots, hopefully you've seen them before. I'm just going to kind of introduce them with this example right here. So some guy named Larry Bird plays basketball for his high school. He wants to improve to play at the college level. Maybe he'll make it, maybe he won't. So he notices that the number of points he scores in a game goes up in the response to the number of hours he practices his jump shot each week. And so he records the following data. And as you can see, we have a list of X's and we have a list of Y's here, where X's represent the hours practicing his jump shot, and Y is going to be the number of points that he scores in a game. What I want to do is I want to construct a scatter plot and say what Larry thinks appears to be true. Now we're going to have to do this both by hand in the graphing calculator and maybe even in Google Sheets. If we're going to do it in Google Sheets, I'm going to come back and show it to you later, because I know I'm not doing a lot in Google Sheets from here on out. So I'm going to go ahead and show this to you by hand first. And so I'm just going to start with two, hopefully very straight lines. And what I'm going to mimic here is actually our graph, an XY coordinate system, where this is going to be my x-axis and this is going to be my y-axis. And I look at my x's, and it looks like if I count by ones, I can get them all on here. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I don't want to make 36 little hashes going up the y-axis. So again, I'm going to scale this to make it so that everything fits. So maybe count by fives. 5, 10, 15, 20, 25, 30, 35, 40. That will get them all on there. Put a little 5 right there to let me know that you're counting by fives going up. Or you can just kind of label everything as you go. You don't have to label everything, but get some key points here. Same thing down here. Even if you're going by ones, count them out for me. Or skip every other one, something, so that I can follow it. So if you want to, grab some graph paper when you're working this. It makes it look a lot neater. This is my second time making the video. The first time I did it on graph paper, but the audio wasn't agreeing with how I was working it with the other way. And then from here, I'm just going to be plotting x, y points. I'm going to be plotting 5, 15. So that means I go over to the right 5, and then I go up 15. It's a lot easier on graph paper, I'll say. And then I go to the point 7, 22. So all of these are just going to be x, y points. 7, 22. My shadow's getting in the way on my smart board here. 9, 28. So I go to the right 9, up 28. 10, 31. 10, just a little bit above 31. And 11, 33. 11, up 33. And 12, 36. So right 12, I'm going to go up 36. So not just a perfect straight line, okay? We're not going to connect the dots yet. I've always had someone that wants to connect the dots. A scatter plot is going to look just like this. It's just going to be a scattering of plots. And I'm wanting to know if what Larry thinks appears to be true. He's thinking that the more hours he practices, which I need to label down here, hours practice, that his points will go up. So this is going to be points over here. And sure enough, it looks like that because I see this trend in the line as he goes. So that's going to be good. Now, it's not full points on this scatter plot yet. Do you see what I'm missing? I am missing a title. Maybe like basketball is for the birds. Basketball's for the birds. That sounds good. Like I said, there's ways to make it look better on a graphing calculator, on Google Sheets. And so I'm going to briefly talk about this real quick. And so on the graphing calculator, I can pull this up. Oops, I already did all my work on here. but I can hit, I just want to show you under stat and edit. What I did was I typed in all my X's here and all my Y's here. And so I have the number of hours that he practiced, and then he scored 15 points that game. And if I come up here to second stat plot, second Y equals, I can turn my plot on. I can tell it what type of graph I want, where my X list is, where my Y list is, what mark I want to use, what color I want to use, and I'm ready to graph. Now, like I said, I already did this problem earlier because it's the second time I recorded it, but if you don't see these points right here, you can cheat real quick by hitting zoom and then the number 9, zoom stat right here. And it will take you directly to this. And if you look, this graph looks the exact same as this graph that we did here. And so I know that we're good. Okay. What's going to be harder on the graphing calculator is that they're not going to have all these little ticks labeled. Okay, so you'll have to use the trace feature to get these points. But it's a good way to check your work, and it's something that we're going to use in the future in this class. Now, how well all these points line up, we are very interested in going forward for the next 3 weeks in class. So I just want to briefly talk about it before we get out of here. And so looking at this first one up here on the upper left, I guess we can label, I'll call it A right here. I look at it and there's 3 things I want you to tell me about this pattern. I want you to tell me whether it's strong or weak. Well, nothing's going to be perfectly strong, but I can, if I was to draw a line through the middle of these, all those points are really close to that line, meaning that my relationship is going to be strong. Next, I want you to tell me whether the relationship's positive or negative. It's going to be positive if both my X's and my Y's are increasing. Or another way to think of it is this line again that's going up through there. The slope of this line would be positive. Next, I want you to tell me whether it's going to be linear or not linear. Linear means that all these points line up in a straight line. And sure enough, these do line up in a straight line. And so I want to see those 3 words when you're describing a pattern on a scatter plot. Let's look at this next one, B over here. It looks very similar, does it? Now, if I draw a line through the middle, I have this guy hanging out right here. It looks like he's going to be an outlier. However, I haven't done the test on it yet, so all I can call it a potential outlier. If that guy wasn't there, I would have a pretty strong, same as I had before, linear pattern. It's still going to, I would still say that it's strong. And it's still positive because it's going up to the right. Positive. And I would still say that it's linear. And that would describe linear. And that would describe the pattern. However, it does have this potential outlier hanging out here. So I would want to mention something about it with potential outlier. All right, working our way down. Let's do C right here. What do you notice different about C? I would say those points line up pretty well still. They're still pretty strong. I would still say it's linear, but look at which way the line's going. As my X's get bigger, my Y's are going down towards the bottom. So instead of being positive this time, it's going to be negative. And again, I can get that because my slope of this line would be negative. That's coming soon. We're going to be talking about slope and how to interpret it. It's still going to be linear because it lines up in a straight line. And that's the pattern. 3 words to describe all of these. All right, well, what's different about the next one? It almost just looks like I randomly scattered all these points, but I didn't. I can tell that these points, if I look at this one and as I move to the right, I see that in general I'm moving down to the right. So if I drew my line, if I try to draw my line halfway between all these points, I see that my line is going down to the right. But the difference this time is that my relationship's not going to be nearly as strong. So I would call it a weak, and it's going to be negative because my line is going down to the right, a weak negative linear pattern. Weak negative linear pattern. Okay, this next one, it looks like something from pre-calc A. As you can see, the points are actually lining up in a curve. It's an exponential curve. And like I said, at the beginning of this, we're not worried about anything that's not going to be linear. And so all I would have to write on this one is that since it curves like that, it's just not going to be linear. If you take another stats class, they might talk about this type of curve in there, but we're not going to hit on it very much in here. The final one is this bottom right one. I guess that would be A, B, C, D, E, F. And it looks like I just gave a 3-year-old a pen and told them to make it look like it's snowing. I can't tell if the line's going up to the right, down to the right. I can't tell if they're not lining up whatsoever. And so what I would write on this is that there's just no pattern to this. No pattern at all. Wait on that end. There it is. And so this is, you'll see some similar to this in the problems I'm assigning and on the upcoming quiz. So you need to be able to describe this, and we'll eventually be able to put some numbers to it and figure out what those numbers mean and how well they are used to measure these points. So here's some good practice to get a hold of, and good luck with it, and let me know if you guys have any questions, and I'll catch you guys next time.